I met Dr. Z at AAPT meeting last year. He's an associate professor at Columbus State University, so he'll be giving us a presentation on his research area. So this is something that
so he got it wrong. This is not my research area.
Sorry.
This is something I do for fun, and I hope you guys are going to have some fun with it as well. What I'm going to invite you today is to use what you already learned in physics and what you're going to learn in physics in a way that is not really mainstream, let's say science or mainstream engineering. But you already have it all. So this is just kind of an additional layer how you can milk the good stuff for more. The topic is Nature My Teacher, and basically we're going to try to use physics laws as analogies and metaphors to how life works in general. And I'll propose a few ideas to you, and then you decide what you can do and how far with it and how far it goes. Now, before we start, how many of you are physics majors? Engineering majors? Okay, engineers, all right. Well, good enough. You do have physics majors here, right?
Yeah.
Okay. Alright, so let's get started. Physics of success principles. So I presented this at the AAPT meeting, and they really liked it enough to think that you guys might benefit from it. How many of you guys heard of Jack Canfield? Have you heard of Chicken Soup for the Soul series?
Yeah.
Okay, so that's the guy who started it. This guy sold like gazillion of books and is a kind of a prototype of what we would consider today a success. This book that he compiled, The Success Principles, is something that I really warmly recommend to all of you for any venue of life. But it's kind of interesting to try to see if there are any parallels in what he's suggesting as success principles and what you guys are learning from physics. Like it's just totally regular physics book. And this is the parallel that I'm talking about. It's a little bit a stretch, all right, fine. But let's give it a shot. Let's give it a shot and see how far it goes. This guy was in prison for murder. You saw this title, right? Yeah, amazing. And so he said, I've never questioned my understanding of the world until something happened, and physics had to do with it.
Safecracker approached me with a tennis ball and a heavy ashtray and asked me, if he was to drop these at the same time, which would hit the ground first? I couldn't believe the stupidity of such a question. Watching those two objects hit the ground at the same time blew my mind. I had never questioned my understanding of the world. I had always just assumed that the world was the way it appeared to me. Yet this demonstration made me wonder what else I thought I knew that I could be wrong about.
So, in short, what happened after this is the guy graduated from high school, which he didn't by the time he got into the prison. He got his bachelor's degree in psychology and then master's degree in philosophy, I believe. And he was on his way, 2 years into his way into PhD in psychology before the time he got out of the prison. Now, how far does that go? A demonstration of an ashtray and a tennis ball falling down at the same time to completely change his view of the world and asking himself, okay, what out there is still that I may not know? Because when this guy asked him the question, he was like, how stupid that is. Of course, the ashtray, the heavy thing will fall down sooner. So he learned from nature. He learned from this natural law and extrapolated that to life. This Edwin Pagan is like a productivity and internet marketing expert and guru, sold dozens of millions of dollars worth of products. And he's using physics when he's describing how to overcome gravity. So he's using this parallel from physics to say, okay, you have this gravity that will first try to pull you down when you start, but you have to get some momentum, and then until you get the escape velocity, you have to keep pushing. After that, it's all down the hill. But he again is using physics to extrapolate as analogies to something that can then serve as useful guideline for life. There are other ways, and you guys are engineers, so you'll like this one. Fiona Fairhurst was charged to develop the swimsuit for the sport, for Olympic athletes. So what she did, she decided to learn from nature again. She went to the Museum of Natural History and took the sample of shark skin to see the texture. And then he found a textile, or whatever could be the closest thing to what she saw is the texture of the shark skin. She got all kinds of rewards for this swimsuit, this fast skin, that's what it's called. And today it's a standard. So she used the nature and learning from nature in another way. Jacques Cousteau developed what he called aqualungs, which is basically the first version of what we know as scuba diving equipment, by observing how the water spider takes the air. This is the only spider that lives under the water almost the entire time, but he needs air. So he creates this silky bowl and grabs the air under its hair somehow, brings it down, fills this with air, and lives under. There's food, it's sheltered, so it's a good life for him, but this guy took it on a whole another level, and created what we know as scuba diving equipment. Path of least resistance. This guy, Robert Fritz, he used the analogies of the electric circuitry, simple electric circuitry, to kind of draw analogies to how, if you want to accomplish something, and if you want to avoid something, then create path of least resistance down the line that you like. I don't know, some example comes to mind. Let's say you want to eat less of sweets. Well, then don't put the chocolate in your fridge, right? Create the path of least resistance down the path that you want to follow, and then create some hardships on the path that you don't. The guy wrote the whole book on it. This is another example that he's using from nature. If you have how to understand that you have to know, if you want to accomplish something, you have to know where you are, and you have to know where you want to be. If you know only one of these two, it's like having this loose rubber band. If you just know where you are, it's hanging loose. If you just know where you are already, it's hanging loose. But when you know where you are and where you want to be, this creates this positive tension that kind of starts dragging you toward your goal. Well, here's a quote from Dalai Lama. The law of action and reaction is not exclusively for physics. It's also of human relations. Now, this is the third Newton's law, and this guy's spiritual teacher, he says, well, take it a little bit further than just constructing the bridge. Oprah made a whole life class on it. It's called Third Newton's Law. It's actually pretty good. They went to, again, Museum of Natural of Sciences in Chicago and had a physicist do the demo for her. Buddha was the original learner from nature. He was first a prince, and to make the story short, he figured out that the life of opulence and avoiding to see the reality is not the path to enlightenment. He went out and became an ascet and almost died of hunger, and then he realized that's not a good deal either. And then one day, when he was meditating by the river, a music teacher passed by in a boat. These are screenshots from the movie, Little Buddha at school. And so the music teacher passes with his student, and he says, you have to tighten the string of the instrument just right, because if you tighten it too much, it will snap. And if you do not tighten it enough, it will not make sound. It just has to be right. And so he then realized, okay, neither of these two extremes is the path, is the middle way. And Buddhism today is known as the middle way. So this just one insight from the principle of nature created a major world religion, basically, of today. Now, I was in India in 1995, and I visited this spiritual teacher, and during this visit he told us, observe the nature and learn from it. Nature is the best teacher. And universe is the best university. So when I heard that, I was 23 at the time. I was also already a physics student. My question became, if nature is the teacher, what's the teaching? If nature is the teacher, then what is the teaching? And I spent basically a lot of time after that figuring this out. And what I'm presenting here, this 12-part framework, is the result. All right. So the first quadrant has to do with how you carry yourself, your being. And here I put the law of reaction, action and reaction, so third Newton's law, but also the law of reflection. I'll get into that in a moment. Because this speaks to take into account what you're doing, because it does create effect. Right? The entirety of science is based on the idea that all the effects have their causes. Because if they did not, then there'll be nothing to do research on. So every cause has its effect. Every effect has its cause. And so the third Newton's law kind of illustrates it the best. Every action has equal and opposite reaction. Of course, it's more complicated than just one way, two-body interaction. But nevertheless, it's a good place to start. The resonance. I'll show you later on. I'll get into that. If you have two tuning forks and if they're at the same frequency, if you hit one of them, the other one picks up the energy. If they're not at the same frequency, it just doesn't work that well. I'll get into that in a moment. But why is that important? Because, as I'll show you, we are creating electromagnetic waves all the time. Our heart is pumping the blood because the muscles are contracting, because the electric current is passing through them, the brain is emitting the waves. So that's why you can create that electroencephalogram, right, of the brain and electrocardiogram of the heart, because it's electric. It's electric bioelectric machine. So that is creating electromagnetic waves. And so you are emitting these things, but whatever the frequency you're at, you are also receiving at that frequency, just like radio station, right? You're also, whatever you're emitting at, you're also being a receiver for that frequency. So it's important to kind of tune up to whatever is productive for you. And I'll show you later on some research on this. And then the energy states. These are analogies from quantum mechanics. If particle is in different energy states, the probabilities or distributions of probabilities that anything will happen or you will find that particle anywhere dramatically change. What may be the largest probability in one energy state, for example, the ground, is the smallest probability in the next one. So, again, using it as an analogy, your energy state, regardless of what are the conditions, regardless of what kind of potential well you're in, will determine the probabilities of the possible outcomes for your life. Now, all of these, as I said, deal with how you're being responsible for your life, taking responsibility, not responsibility in terms of guilt of any kind, but ability to respond ability. The second part deals with, so this is about being. This is about envisioning where you want to go, what do you want to become. Law of conservation of energy, right? So if you have a closed fish tank like this, completely sealed off, technically you can technically create conditions that it's pretty well isolated and all of the energy inside is conserved. But life inside cannot be supported. All of the energy is conserved because of the entropy. These types of energies are not deteriorating from the kind that you can use to sustain life to the kinds that you cannot. Now, what are even if you have just light coming in, algae can survive inside for years, just if you have light coming from outside. So what's your solution? If you isolate yourself in a closed system, all the energy is still there, but you're dying. So what's the solution? One possibility is to make the system larger, right? And making the system larger basically means becoming part of the community, part of the society, and then figuring out what kind of little wheel inside it you are. So what you're part of, and how do you belong in it, and what is your little role in it. Once you know that, you can sort out what are the kinds of filters or biases that you have when you're observing reality and try to deal with them one way or the other, knowing one way or the other that you're seeing only a tiny little bit of spectrum, right? All of these are little, well, this is, physics 1 and 2. And then you can focus on what you want to accomplish, right? Because focus gives you a whole lot of energy, and being aligned creates effects that, right, like magnetic domains creates effects that you don't have if things are just scattered. Well, once you know where you want to go, you just do it, right? Just do it comes as the third step. So take into account that you have to build up momentum. It's not going to fly right away. Yeah, and depending on what your masses are, what the resistances are, it might take a little bit of time. But start on and keep in mind that the trajectory has to be well directed, because tiny little angle of off your course will create a large discrepancies when you arrive, or when you think you arrive at the goal. Accelerate. So now you can go into the mass systems. Actually, let me just jump into it. So that thing will have acceleration that's equal to, so the pulling force. Let's include the friction. So the pulling force is down this hanging mass, or the hanger G, minus, I'll include friction. So the mu m on the table, let's call it m mass on the table, G mu, that would be normal force, right? And then over m h plus m on the table. Look at this equation. How fast you're going to accelerate, what the acceleration is going to be, is going to depend on all the forces that are involved. This is the pulling force, right? This is your effort. This is what you are trying to, this is the work that you put in your study time. This is the friction. The forces that act against you, right? And, not sleeping properly, not eating properly, right? I don't know what these may be. And then you have the total inertia of the system that's acting against you again. Now, inertia of the system may be bad habits, right, or whatever they are. So, your acceleration, resultant of the forces over the inertia. So I get into these kinds of analogies for that. Check out what are your good forces, what are your retarding forces, and what are the habits that are not productive in what you're trying to accomplish. And then do the flow. I already mentioned this, right? If you have parallel circuitry, you want to create little resistance down the path that you do want, and a whole lot of resistance down the path that you don't have. And then finally, so this was B, envision, or C, do, and finally expand. So, uncertainty, deal with it. It's unavoidable, right? Life is as it is. Uncertainty is unavoidable. Entanglement, things are more complicated than we can think of. Be careful what you entangle with and what you disentangle with. How about just taking care of what company you associate with, right? That'll be this one. And then the universes. Well, if it's true that every possible decision point creates bifurcation in universes, and there is infinite number of them, well, we don't know, but hey, let's just take it for a ride. If there's infinite number of them in which, that means that everything that you possibly want to accomplish has been accomplished in some other universe. It's your version of you in some other universe that already accomplished that. Now, just for a ride. What you can do is to sit down with yourself for 5 minutes, close your eyes, and then think, what kind of advice would your doppelganger give to you to do that in this universe? How cool is that? Now, if the only thing that gives you is just this stretch of imagination, hey, good enough. I don't know if there's an infinite number of universes. They say they probably are, or maybe are. But it's a good stretch of imagination, one way or the other.
Well, it is totally mathematically consistent with all theories of quantum mechanics and gives us the results that traditional quantum mechanics gives us. So
there you go. So better visit. Okay, make a 1:30 p.m. appointment with your doppelganger.
more ontology.
If it was only once.
But you're right. This is kind of
Yeah, ones that are doing well, right? You don't want to meet those that are in ditches somewhere. So, as I was thinking, I came across this book not too long ago, and I was thinking about 30th law and resonance and all this, and then I got across this book, and the first law in this book, out of 64, says, take 100% responsibility for your life. That's coming from empirical coaching. That's not philosophy, that's not physics, not science, it's just coming from empirical coaching. This doesn't mean that you are guilty for this or that. It just means that you are better off. You're better off if you take life as if you are the one who can make change about anything that's happening. As long as you take or believe that it's somebody else, something else, either weather or government or your friends or your parents or your grandparents, you are powerless. All right, it may be, who cares? But you are powerless. You just gave away all of your power to the dead people. And you cannot do anything about it. So forget it. Pretend. I don't know if we are responsible for everything in our life. It doesn't matter. But let's pretend we are, because that takes our power back. That takes a responsibility in terms of ability to respond. Okay, here's what it is. Here is where I am. Let me take ability to respond to it the way I like, to make another move that will create another reaction that will bring me closer to where I want to be. So the third Newton's law. All right, let's play a little bit. Why is it not obvious? And you guys, this is the first time I'm presenting to physicists and engineers other than that APT meeting. But typically it's kind of a mixed crowd, so I do this little question and a few demos. So when you compare the force of that force with which the Earth is attracting the apple down, and the force with which the apple is attracting the Earth up, how do they compare?
Insignificant difference in between the force that the apple pulls up on the Earth and the Earth pulls down.
Insignificant difference. Where's this insignificant difference coming from?
The amount that the Earth is pulled back up is insignificant in comparison.
Okay. So let's compare the forces first. We'll get to effects. Let's compare the forces. How do forces compare? Force of the Earth on the apple, and force of the Earth on this thing. How does it compare to the force of this thing on Earth? As this thing falls down, how do those forces compare? Which one? Let's say, let's go. The force on the apple exerted by the Earth is greater than, equal to, smaller than. To not make biases, why don't we vote? So this is A, B, C. Can you just show me your answers? A, B, C. So, okay, that's not an option. So I see all three answers actually, and there's a lot of ones. Okay, so let's. So the one said that the force that Earth exerts on this is greater. Right? Now, if we are to believe the Newton would say every action has equal and opposite reaction. So the Earth exerts the same force on the apple as the apple exerts on Earth. That's what Newton says. Now he's an old guy, so we might not trust everything he says. Right? So let's try to see if we can make these different. Can I have two of you guys please help me with this demo? So what I would like to accomplish is that we get different forces exerted on two different objects. And so this is a scale of 20 newtons. And if you grab on one side and if you grab on the other side, just so that they can see as well. So what I would like you to do, you're a little bit taller, so I would like to start so that you exert greater force on him than he does on you. So you just stand there, don't pull anything, and you pull a little bit. So I see here just 17, and this is 17 again. And now you went to 19, and then he went to 19. So I want you to let go. So don't pull. Let him, okay? Let him. So, but now you let it go. Now it's 12 and 12. So can you accomplish so that you are pulling more on him than vice versa? Okay. So maybe you have to let go a little bit, or maybe you pull.
Maybe I pull.
I don't know.
That's fine.
Because
how's this done? Okay.
I don't know. What could we do? Because you guys are having exact same amount all the time. So why don't you try this? Why don't you just hold? Being strong, just hold it and then you pull so that you exert great force. And no. See, it's a problem. So, thank you.
It's blowing my mind.
Yeah, it's mind blowing, right? So, what's the conclusion of this? Can he ever pull more than he does? Can these two forces ever be different?
Depends who he's moving.
Thank you, you guys. Let's give them a clap. Good job. Okay, can somebody tell me the point? Anybody? All right, I just saw it.
Go, what do you say?
It will always be the same. You just cannot avoid it. It will always be the same. Now, it's easy for us to see that when I'm pushing this wall, the wall is exerting this, same force back on me. That kind of makes sense. But Apple and so this was a little bit more tricky. But then Apple and Earth, what the heck is going on there? How in the world can Apple exert the same force on Earth as the Earth does on the Apple? And so, well, if you take the law of gravity, you know the formula, right? G m1 m2 over r squared. Right? Does it matter which one you plug first? M1 or M2? Does it matter? So the law again says it's same. Does it say which one, which gravitational? Does it say which one is it on? Right, force 1 and 2, it's same, right? So the number is same, but then something is missing because the apple is falling on Earth, and Earth does not seem to be falling on apple, right? This thing's falling down. Earth is not jumping up. What's the catch? There's more to Newton. What else this guy said? He has 3 laws. Come on, people. This was the third one. He said one. He had 2 more. So which, actually, the first one is a special case of the second one. So what's the second one?
Force is equal to mass times acceleration.
Okay, let's put it this way. Acceleration is equal to force over mass. So what happens with this thing is if you have a certain force and you have small mass, that'll give you large acceleration, right? But if you have that same force, and you have large mass, that'll give you a small acceleration. So the forces are same, but the effects are not the same. The effect of this force on the apple is hugely disproportional, hugely larger than the effect of that same force on the Earth. So technically the Earth is jumping on you. When you jump, okay, I'm going to shake the Earth now. Just watch me. Right now. Okay, ready?
Yeah. Ooh.
Now, the acceleration of it was very, very, very tiny. Right? The mass of it is 10 to the 24, right? Mass of the Earth, something like that. So the acceleration was so small, and I'm pretty sure somebody down there in China was maybe jumping at the same time, so it might have canceled. But nevertheless, these forces are same. The forces are same. It's the effect that's different. When you have a let's say big truck on a highway, and it smacks a tiny little poor bug. How does the force of the truck on the bug compare to the force of the bug on the truck? Same. But those 2 same forces are acting on 2 different things. And that same force is not going to do much to the truck, but it's unfortunately going to do a whole lot to the bug. It's the same force, right? So what we confuse is the force with the effect of the force typically. And this is why we don't see this way. Now, just in the interest of time, I'm not going to explain why the donkey pulls the cart. Because if these forces are same, if whatever the force the donkey is pulling with is equal to the force with which the cart is pulling on the donkey back, why would they ever move? how about this? Ask your physics professors. Because the short answer is yes, indeed, these forces are equal and opposite, but there's a whole lot going on down there with you.
Mhm.
So, wave reflection. Waves reflect. And that's important because we are wave generators. Let me show you this.
Actually, most interesting to me is the electrical heart. The heart is an electrical organ. It produces by far the strongest source of bioelectricity in our bodies, up to 40 to 60 times stronger than the second most powerful source, which is our brain. This electrical energy permeates every single cell in our bodies and is so strong it radiates beyond the skin out into space. This electromagnetic energy in this field changes depending upon our emotional state. This is where it gets really intriguing. If we're experiencing strong negative emotions like anger, frustration, resentment, all those things we can often feel, it produces an incoherent spectrum in this electromagnetic field. Conversely, if we begin to experience emotions, the same ones I mentioned before, long metaphorically associated with heart, love, care, compassion, kindness, appreciation, tolerance, patience, non-judgment, those kind of things, it produces a coherent spectrum in the field. And we are broadcasting this electromagnetic energy to every single cell in our own bodies and then communicating it outwards into space. We can measure some of this by looking at what's called our heart rhythms. The medical term is heart rate variability analysis. Now, once we discovered all this, we developed technology, software that can measure changes in our heart rhythms, display those changes, and then determine the quality of them by using what's called a measurement of coherence, divided into low, medium, and high. And right now, I'm going to demonstrate that for you in real time and show you how powerful this really is. So I have a willing volunteer that I met backstage just a few minutes ago, a very brave young woman named Allie, who's agreed to come out here. Allie, if you would join me on stage. And this is what her heart rhythms look like right now. Now, she's up here on stage in front of a whole lot of people. I've already let you know that these heart rhythms reflect internal emotional states, so I'm sure there's no reason for her to be nervous. And as you can see, there are changes occurring in real time.
So what he is doing, the computer is analyzing, basically Fourier analyzing the waves, and then the degree of incoherency is telling the emotional state. Here, just divided into three, like bad, kind of medium, and nice, coherent. And he can tell that she is really stressed because all the frequencies are just all over the place. But the thing is, this is changeable in no time.
As we do this, now what I want you to do is I want you to close your eyes. And I want you to focus your attention right in the center of your chest, right in the area of the heart. And now I want you to breathe naturally and normally. You're okay, I'll let you know what's going on. Breathe naturally and normally, but just a little bit deeper than you normally would. Nice deep breaths. And as you do, I want you to pretend as if the breath is flowing in and out right through the center of your chest. This is called heart-focused breathing. By the way, you're doing just fine, dear. Now I want you to stay with that heart-focused breathing.
Do you see how it changes?
And now I want you to feel a positive emotion. Maybe it's the love or care you have for.
So it changed in no time. Right? It shifted in no time. And the other thing I wanted to show with this is this is Heart Math Institute.
What we found is that there's an evidence of a global effect when a large number of people create similar outgoing emotional waves, whether stressful and incoherent or positive and coherent. There's a global effect when a large number of people are experiencing something similar emotionally. When there's a natural disaster or some kind of very bad news, don't you kind of feel that in the air?
So this can be now measured. The effect that a whole lot of people not feel if something happens, and a lot of people hear the same news at the same time. This can be now measured as a global effect. So the key point there is that this wave output depends on our emotional state, and this is how frustration looks like, and this is how appreciation looks like. If you compare that to music, that's how noise looks like, and this is how a nice tone of violin looks like. So compare that, this and that, like straightforward. and this is the field that we have around. So what we are doing, by all the electric activity inside of the organism, we are creating this electromagnetic field around us, and we are sending the electromagnetic waves into the surrounding. What waves do is few things. First, they reflect. Right? Waves reflect back. That's kind of analogous to the third Newton's law. Action and reaction, they come back. Second thing, they resonate. Which means, okay, so here I have two tuning forks. They're at the same, these are at the same frequency, and what happens is if I hit one of them, the other one starts vibrating. And it goes back and forth, right? If they are at different frequencies, now these are not working as well as these, but I can change frequency with these. In any case, if they're at the same frequency, so roughly same frequency, or the other way, that did not work as well, right? But if I change the frequency, if I just change this frequency a little bit, and I do exactly the same thing, it just doesn't care. It just doesn't care. It doesn't pick up. This is just like a radio station, right? You tune it just to the right certain radio station, and you're picking all the energy from it. Well, you need an amplifier, but nevertheless, that's what you're picking up. Everything else is really steeply, when you look at that curve, or resonant curve, it's really falling down steeply on both sides of the resonant frequency. And you, by creating this field, you are creating resonance for yourself. You are resonating with something. So, the frequency spectrum that you're creating with your emotional state is going out, being reflected back, but it's also feeding you from other frequencies. Other people that are at the same frequencies are feeding your field. You're becoming open to whatever you are vibrating in. And then there's final thing that I thought of actually just recently. So there's interference. Yeah, this is the brainwaves, right? I mean, so we're just getting this stuff out. But what I thought just recently about is, how many of you took physics 2s already? How many of you know what self-inductance is? Not yet. Okay, so there's this phenomenon that if you have a current-carrying wire, it creates magnetic field around itself. But if magnetic field changes, that induces the electric current in the wire. Now here's the funny thing. This wire is affected by the field that it creates as if it was something external to it. So it creates the magnetic field around itself, and then it's affected by it as if it's some external agent imposed on it. So when the current that creates this field changes, you get a changing magnetic field, and then that induces another current in the wire that's opposing the change. So why I'm saying this is, who is the first under the effect of the field that you're creating?
Yourself.
You are yourself, first one. You don't have to wait for the reflection. You don't have to wait for the resonance and the other people input. You're doing it to yourself first, before anything else. And then classical and quantum mechanics. Just going back to that analogy that I used before. So these are the wave functions of different energy states in a potential weld with either infinite or with certain finite. Well, when you square these functions, you get probabilities of the distributions by which you will find these particles somewhere. So if you square this thing, you get a bump like that. But if you square this, you get two bumps. Which means if the particle is in this energy state, everything else is the same. Circumstances, right? The world that is in, or whatever they are. Here you have the largest likelihood of finding it right in the middle, in this energy state. If nothing else changes around, but the energy state of the particle, meaning your energy state, right? Your emotional state, in this analogy. In this energy state, this is the least, or basically you have zero probability of finding it here. So what was most likely here is very, very unlikely up there. And then, you go on to different states. So I'm not this is not science, right? It's not straightforward science. I cannot tell you, okay, be in this energy state and then that will happen. But what is the take out is that whatever you want to accomplish, there's different energy states that is creating the greatest potentiality for it. Right? If you want to get get well or along, be friendly with your colleagues, well, there's certain energy state that's most conducive for it, right? If you become grumpy, well, they might like you still, but it's just probability is not that high, right? Or you may come in, all fresh and smiley, and they say, "What a jerk!" So it's not guaranteed. It's not guaranteed, but there's this probability distribution, right? So these are the basically likelihoods of finding electron around the hydrogen atom depending on its energy state. So this energy state has a whole different life than that energy state or that energy state. So which life do you want to have? Well, pick one and then get into the state that corresponds to it. Okay, I'll skip this and skip that. Okay, so this is a funky slide. So physics says every action has equal and opposite reaction in all kinds of versions that I was telling you about. That's Newton, what he says. The Bible says what you saw socially reap, basically, in short, right? What you saw socially reap. That's pretty simple. In Eastern religions, you'll find the law of karma. Your life is your doing. That's what it basically says. Your life is your doing. And then you have this guy. He says, take 100% responsibility for your life because of this and that. It's kind of funny, right? Newton and Buddha and Jesus and Jack Canfield. I kid you not, when I decided to present this to AAPT, to 40 physics professors, I was nervous. I thought someone would throw me out of the room. Alright, so what Jack Canfield says is to take responsibility for your life, give up blaming, complaining, justifying, defending, excuse making. Simple, right? So, because, you never find people complaining about gravity, for example. It's an old man saying, effing gravity. No, he'll say, effing life. He didn't, get me on time. So, they complain about things that can be changed. People don't complain about things that cannot be changed. They complain about things that can be changed. And they complain about them because they are not willing to do what it takes to change them. That's what complaining is. So whatever happens, right, what the outcome is, something happens, then you have your response to it, and that determines the outcome. It's a little story. So there was a Lexus car dealership in California, and they were doing quite well, and then the first Gulf War started. And the sales went just down the drain, and what they decided is to change the strategy. They took their fleet to places where they thought might be people who might, like golf courses, so people that might buy that. So they come over and say, hey, we like the car, we have this new, type going out, would you like to sit and just, have a drive? And then the guy sits in and he just likes it and decides he cannot live without it, and he cashes it out. So what happened is that after they started doing that, which they never did before, their sales surpassed the level before the war. And when everything was back in normal, they continued doing this. So the outcome, the event is whatever the event is. But it's the response combined with that determines what actually happens. And this is your point of power. This response is your point of power. Again, I'll have to skip this. It basically shows you how your muscles weaken if you lie or if you think negative thoughts, if you project negative opinions, your muscles just weaken up. Even if you're saying your name, if you try to say your name and then you try to say, why don't you do this for yourself? Just quickly, stretch out your arm kind of notice how strong you are and say to yourself, my name is, and then say your name. And just notice how strong you are. Just kind of calibrate how strong you are. And then think of somebody of the opposite gender. Somebody, man, think of some female, woman, think of some man, distant relative, or I don't know what, much older than you, or much younger than you, and then keep that arm again stretched out, and then say to yourself, my name is, and say their name. My name is. Do you notice how you weaken? If I was pressing you on your arm would now just sink down. And earlier when you said your name, my name is Desla, you hold strong. My name is Jane. Because your brain basically turns off for a moment to figure out what the heck is going on, right? It basically says, okay, put brake on the pedal because I have to figure out what's going on. That's what your brain does. That's why it's not. You cannot be. It basically pulls the power from you. And when you think negative thoughts, same thing happens. So here's what I have for you. If you would take that handout that I gave you, think about a few things that you could do. Just a few things that you could do. And if you would take not 100% responsibility, just not 100% responsibility, but just 5% more responsibility for your life. What could you do now or today that you did not before that will make your life better? Three things in each one of those. So for the well-being, what could you do? It can be tiniest thing in the world. I would get up 15 minutes earlier. I would have lunch within 2-hour range, not within 5-hour range, right? My lunchtime. I could exercise 7 seconds. Just 5% more. You can do that. Just 5% more. Don't be hard on yourself. Just put something that you totally can do. Something that's totally doable. It doesn't have to be big. It's just totally doable and something that you will like, something that you will benefit you. So for your well-being, for attainment of your goals, relationships. Let's do those 3.